Hey everybody, this is going to be over reading discussion 14, the folded triangle problem. We're trying to maximize the area of the triangle using calculus this time. So we know we start off with this sheet of grid paper that's 18 by 24, and you want to fold down this point to be somewhere on this segment down here. So we know we're going to fold, we're going to get a height of x, and then the hypotenuse here has to be 18 minus x because the fold down from A to P is 18. X is going to be from A to wherever the fold starts, and then this is from where the fold started to wherever P went. So 18 minus x will show us that. Then we can find the base by using Pythagorean theorem here. Solve for base, we're going to end up with square root of 18 minus x squared minus x squared. Okay, so now we can formulate our area with respect to x. It's going to be equal to 1/2 times height times base. Okay, now that we have our formula here, we can find our domain. We know x can't be less than 0, so it has to be greater than or equal to 0. And then to find the other bound, we use the base here. We know this has to be greater than or equal to 0. So, square both sides, multiplying this binomial, we get 324 minus 36x is greater than or equal to 0 because the x squared is going to cancel here. All right. Now we can move the 36x over, so we're going to have 36x is less than or equal to 324. Divide by 36. I'm sorry, and we're left with 324 divided by 36 is 9. So we know that x has to be in between 0 and 9 for this area function to work. Otherwise, it'll be undefined. Okay. Now, for maximization, we know we have to do a first derivative of the area function here. So we do area with respect to x prime is going to be equal to, let's see, I wrote the derivative out because I knew this would take me a minute. So we got to use product rule. So we could take the derivative of the first times the second, right, plus the first times derivative of the second. Derivative of the square root of 18 minus x squared is negative 18 over the square root of 18 minus x squared. Okay. Simplifying this down, we can break this down to 324 minus 54x all over 2 times the square root of 18 minus x squared here. Now, since we have our derivative, I know we need to find critical points, let's talk about the endpoints here real quick. So the endpoints of our domain, a of 0, is going to be obviously 0. And then a 9 is also going to be equal to 0 because the thing in the square root here is going to be equal to 0. Okay. So we know that it's either going to go like this or like this with our endpoints on the axis here. So now we come down over here. We use our derivative that we have to find our critical points, set it equal to 0. 324 minus 54x over 2 times 18 minus x squared equals 0. Multiply by the denominator here on both sides. Cancel it out on this side. And because we got 0 on the other side, it stays 0. And we can add over our 54x equal to 24. And we know x is going to equal 6 here. Okay, so this is the only little weird part I came to, because most times there's two critical points coming from an expression like this. But I knew that x equals 6 is a pretty good x value. I graphed it and looked at it, and so the area with respect to x when x is 6 18 minus 6 squared here came out to be 3 radical 108, which is about 31.17. So that means that the area of maximization would be 31.17 with the x value of 6, and this is how I would go about finding the maximum value using calculus in a derivative.